Hi guys, Dr. Diaz here again. Now we're going to study the general form of the equation of a circle. Dun, dun, dun. Yeah, this is the one that I said a moment ago. It's very complicated to solve it. And it's because look at the equation. Looks like a crazy stuff there. You have x squared, y squared, dx, y, e, y, and f. And what happened here? How do we solve this one? Well, here you have to apply something that you learned in chapter 8 and chapter 7 and 8, somewhere there. Completing this square. There, you see, that's why the final exam basically says covered 9 and chapter 9 and chapter 10, but actually in order to do some of the problems you need to remember stuff that you did in the other previous chapter. So it's sort of a comprehensive. So the first thing we're going to do is, when we solve this type of problem, is we're going to isolate it or regroup the x variables on one side, the y variable, not one side, x squared with x, y squared with y, whatever's not an x and a y, we send it to the other side as a constant, and then we start solving that problem by doing comparing the square. So let's look at an example. Yeah. Okay, here we have the example. Write in standard form and graph this equation: x squared plus yx minus 4x minus 12 minus 12y minus 9. So the first thing we're going to do is this. We're going to regroup x squared with the x, right? X squared minus 4x, and leave some space here, and then put plus y squared minus 12y, and then whatever's not an x or y, we send it to the other side. Since we have negative 9, when they cross the equal sign, we change the sign, is going to be positive 9. And here's where we start doing the process of completing the square. Look at negative 4, the middle term. We divide it by 2. We square it, which is going to be what? Negative 2 squared is 4. Then we go to do the same thing with the negative 12. Negative 12 divided by 2, and we square it. It's going to be negative 6 squared, and this is 36. And what we do now is we're going to add this 4 here, this 36 here, but if we add 4 here and 36 here, we had to add 4 and 36 this side too. So the equation will look something like this: x squared minus 4x plus 4 plus y squared minus 12y plus 36 is equal to 9 plus 4 plus 36, right? And the reason why we did this is because we transformed this into a perfect square trinomial, and this one into another perfect square trinomial. This one, its factorization is going to be what? X something squared, and this one is going to be y something squared. This is equal to 49, right? Because this is 36 plus 4 is 40 plus 9 is 49. And here's the thing, which number goes here? And look what we're doing. We're taking this equation of a circle, which is in the general form, and we are converting it into the standard form of equation of a circle, which is easier to graph because you will know the center and the radius. I mean, yeah, the center and the radius. In this case, the number that goes here is usually going to be this fellow here, which is negative 2. And the one that it goes here is going to be this fellow here, negative 6. So here we got it. This is the standard form equation of a circle. The center is what? Negative 2 is actually then positive 2, which is h and k, right? And negative 6 is going to be positive 6, and the radius r, which is the square root of 49, is 7. Now, graphing this thing, we have this. Let's go to the center. When x is 2, y is negative 6. So we already can see where 2 is. This is 5. Halfway would be 2.5. So 2 is somewhere here, and positive 6. So that thing must be somewhere around here, the center. Then from here, you're going to move 7 units to the right. So now you know this one is in an x equal to 2 plus 7 will be 9, so it's almost here, 10. Then you go here, 7 units up, you already have 6, so 7 will be 13, so it has to be somewhere around here. 7 units to the left, you already have 2, so it will be in 5 here. Well, 5 here, I should say it, not that one. Yeah, because it had to be equidistant somewhere here. And 7 is down, so we have it already in 5. We go 2 down, so this will be somewhere around here. So this is our circle. Okay. Awful, but it's okay. It must be somewhere around here. This is our circle. Yay! Yeah, you keep doing it and then start looking at the circle. Okay, guys, I hope this example helped a little bit. There are more examples on the review, and I think the PowerPoint, and basically it's the same thing. So doing a recap here, the first thing you do when you get the equation, you regroup x squared with x, y squared with y, and whatever's not an x and a y you send to the other side as a constant. Take the middle term, divide it by 2, and you square it. That number is negative 2 squared is going to be 4, which means you're going to add it this side of the equation and also this side of the equation. Then you take negative 12 divided by 2 is square. It's going to be negative 6 squared 36. You add it here, and you have to add it here both sides. That's what we did in this equation. We add 4, we add 36. The reason why we're taking this term divided by 2 is because we're turning this expression into a perfect square trinomial, which it will be then ended up being in the factor form that we want, which is the standard form equation of a circle. And here immediately we get in the center, right? If it's negative, we know it's going to be positive 2, positive 6, and the radius is going to be the square root of this number, which is 7. Okay, guys, hope this helped a little bit. Take care and see you in the next video, which I think we're going to the next 2 or 3 conic sections, ellipses, hyperbolas, and parabola. Take care. Bye.